Hi everyone, welcome to STE Skills. This is Naga. So every Saturday we have a system design deep dive, and another weekend we normally have mock interviews. We do this alternating, and we rely on presenters, like mostly being the volunteers. Like if you would like to be part of this, please ping me in Discord. And today we have a mock interview, and Hitesh is our interviewee, and I'm going to act as an interviewer. So with this, let's get started with the system design question. Um, Hi Hitesh, I would like you to design a code deployment system.
The ask here is to let me just note down a few things so that I
Yes.
can come back to this document again and see what I'm doing here. So design a code deployment system.
Yes. So what it's going to do is it's going to do the builds from the any versioning tool, and it's going to deploy to the servers, which could be situated across the geographies. I mean, like if you take like Amazon or like Facebook, they'll have servers across the world, right? Like in different regions.
Yeah.
So
you are help me understand this piece. What you're saying is to create a build plus release. One is build, one is release. And these two are two different things altogether. I mean, when somebody is, I just want to understand the scope of the requirement here. Build is something when, it's for everybody who's attending. A build is something where people interact, and do in parallel, make their changes, goes to some steps which generate a build out of it. And that build is may or may not be deployed in X environment or Y environment or so. The release is something that takes this build and put into the machines that are running this piece. So if I understand correctly, your ask here is to design both of them.
Yes. So for the build perspective, you can assume that like the code will have enough information, you need not worry about the different type of languages and everything. So you can just assume that like when you do build, it has everything necessary to run in an environment where it's going to be deployed. So
okay.
So you typically fetch this from any code versioning system. So
question. When you're saying, are you saying that I don't need to create a build environment where your executables or deployment or the resources are created in a way that makes it easy to deploy to release? Are you saying I need to skip this piece or I need to include this piece? I'm just trying to understand that piece.
Let's include, and maybe once we are going through what you're designing, then I may or may not make you to continue with that. So what I meant is like the output of this build should be kind of a binary.
I'm sorry, come again?
So the output of your build phase is generally a binary, which is deployable to this different application servers across.
And you want me to design that also, correct?
Yeah. So yeah, that's kind of a high-level idea of the build phase. It's going to generate a binary, and that binary could be in gigabytes also. And your system should be able to take that binary and deploy the application servers across the world.
Sure. So the requirement here is I will not write too much, in terms of the text here. Design a code deployment system where a build will generate deployable package and a release definition, or you can say a release is another component that is responsible to
take this binary and
things to
develop.
production, things to various servers.
Yes, yeah, that's it. Yeah.
Okay, I'll start with the I'll try to understand a bit more with you with respect to the build environment. I'm going with certain assumption here, and I would like to get those vetted by you. Assumption is and I'm going with the one example specifically, instead of being a little vague here. I will share one example, and I will try to correlate it to what we do today in my team or in places that I have worked. There is a Git repository where multiple folks can collaborate. There is a master branch that is responsible for deployment builds. I'm talking about in scope things of when we say about generating a build system, things that are in scope. And I will also try to see if there is something that I can put in out of scope here. There is a master branch that is responsible for deployment, for creating a deployment, for creating a build that can be deployed to servers, I'll say, or various environments. And let me think of what else in scope. And there's a check-in process or check-in build as well that determines test cases run and is your code appropriate or so, that way. And I'm going
you
with
need not worry about much about testing and all. Yeah, just to let you know. So,
sure. And along with that,
you can just assume that like every day there will be like thousands of or like even tens of thousands of deployments happening from multiple teams or engineers.
Yeah, correct. And there are build machines, maybe in cloud, that is responsible to generate a build out of it. And that's it. So the steps involved in build will be developer. I'm trying to write down the steps so that I can design how the flow will look like. Developer will enlist branch and create a child branch. Make changes and create pull request.
Let's say, like, to simplify this a bit, let's assume that like your build will take a git commit SHA. You have this commit hash, right?
Okay.
So let's take any of that git commit SHA and generate a build out of that.
Okay.
So to simplify this process and all.
So git commit is ready, I believe. What we're trying to say is git commit in master is done.
No. Yeah, I mean, like instead of going through all that process now, let's say that your input to build phase is like a git commit. Like there is a hash for every commit, right? So let's say like if you want to run a build right after that, like you know, like using the git commit what all your code is. So until that point, so you can use that for build.
Okay.
Mm-hmm.
And Okay, so git commit is the first step involved where a check-in is made, and after that, this code is picked. I'm talking about
By
the auto.
your build system. Yeah.
Correct. This code is picked by build system automatically and run on a specific pool of on a specific machine in pool. And I believe I don't need to worry about the things that are required. At least at this moment, I'm keeping few things out of scope here, and I'm assuming those will be, and I can bring them on in if you feel like.
Yeah, sure.
Required resources on build machines are available. Required resources which including including all the things that which is
You mean the language runtimes and all, right?
language runtime, DLLs, NuGet packages.
Yeah. Those all you can assume that they are already there. Yeah.
All right. I'll go with here. I believe I don't have anything as such out of scope here if everything is available in the build machine. I would like to state something here, the way it's expected to work. Every repo, so the trigger here is your check-in.
Yes, correct.
Let me draw here. So I'm drawing here as an actor. This actor is a developer. He makes a check-in to a branch. Now, this branch has set some policies. And I believe this environment, what I'm stating here is as a assumption that that these things are already available to us, as a form of Git repository. I can kick off something here, that as soon as a check-in is made, it can be taken up. So those things are available in the branch policies that, the reviewer, I will start from that point only when the commit is made. So I'm keeping out of things where, reviewers are approving something or so. So things are available in branch, and I will name it a master branch, which is a collaborative branch, or you can say, and master and then children also. And then after the branch, this is a trigger point where a check-in made to a master branch generate a hash, like as you said, and then this goes to, there is a set of pools.
So is this what you are designing? Okay.
Yeah, I'm first of all going with the block level diagram here, and I will explain and go over. So there is check-in that is made to the master by a developer, and then this, and I can definitely, since this is taken as a first step, so I can take a master branch is available, and a check-in is. So once a check-in is made, I think I should.
How do you know,
go on?
Yeah. I mean, you go ahead. Yeah. I just wanted to understand the high-level flow first.
Yeah. When I'm saying a branch policy is something like, a branch itself has a Git repo. So there are some jobs. I don't know how it happens today, but though at least what I know of is you define certain policies at a branch level. When the check-in is made, is to trigger something. It's a push mechanism. Where,
So yeah, tell me.
Yeah. So what I'm saying here is that this piece is, when I'm saying policies are defined here, it means this piece is already in place, or do you want me to write that as well?
So, so let me ask you this way. So you have the developers making commits, and each of those commits is kind of a build. So which is kind of a build task for you. So how are you going to check how many tasks you have at hand right now? because there could be concurrently multiple people can be, it could be this branch or some other branch, but like all of this commits is going to generate a build task for you. So how are you going to like pick those and process? Like what is your high level idea?
I would also like to get some input from you here, just trying to understand what the expectation here is from you. Um, when I said a branch has some policies,
Mm-hmm.
what I mean to say is there is a pipeline. I'll refer it as a build pipeline.
Mm-hmm.
Build pipeline is the one that is responsible to take the code from branch and generate a meaningful build which can be deployed to servers.
Mm-hmm.
Right now, and now this goes like, whenever a check-in is made,
Mm-hmm.
this check-in act as a trigger to generate the build. Now, this push mechanism, when I'm saying there are policies defined, it means with every branch, there is some kind of, polling things that is happening. There are some servers that are polling across, the branches, multiple different branches, and they're looking for if a check-in is made. When the check-in is made, they will trigger a build pipeline, this piece. And I can definitely elaborate that on, there are a set of, I can say, a set of servers, some defined number, and they are simply, responsible to poll, and for every branch. I can go into the detail, but if you would like to, there is some kind of environment which is polling and trying to see the state of a branch, master branch, and if it sees a hash, it is responsible to trigger a build pipeline. And I will, when I said an add,
So, so are these servers like you have some monitoring service which monitors these branches,
yes,
commits,
yeah.
or like are you using the policies to trigger a flow in your server?
When the policy is created, it means you are registering this branch to these servers so that they can monitor.
Okay, okay, got it.
Right. So there is an monitoring server. I think just summarizing this piece. When I'm saying server, you can say it as a monitoring server or monitoring servers, which has registered, a branch. And at every, periodically, it could be a second, it could be a minute or so. It all depends. They are keep up, looking at the branch. Has there been a check-in made? It can be your final check-in, it can be your gated check-in, whatever. A check-in has been made, and depending on the branch policies, let's say the branch ABC, every branch can have a different build pipeline, and this build pipeline is for ABC branch, right? Now, these servers are responsible to get the check-in, like you said, get the hash out of branch, and that hash actually trigger a build pipeline, and this build pipeline is tightly coupled with this branch.
Okay, that pipeline is defined by you.
Yes,
Okay.
this pipeline is
So,
defined, and
so
I will.
what do you do as part of this build pipeline?
Fair enough. You want me to drill into this build pipeline box?
No, no, no. At a high level, what was your idea? Like now that like this build pipeline is part of your system, like code deployment.
Yeah.
So,
In case of build pipeline, well, what we see at this moment, there can be, things that you, like, this branch, when we use a hash out of a branch, which is you can simply say it's a Git repo, or it's a repo actually,
so
whatever has
do
been.
you mean this build pipeline is kind of a queue where you are just monitoring and placing the build tasks? Or
There can be n number of things in the build pipeline, some copying some artifacts as it is from the build branch, dropping it somewhere, and then running it, maybe .NET or Java kind of, there are tasks defined in this build pipeline.
okay.
Right?
So what each task will contain here?
Yeah. Task one, it can be your run test case, if it is take a simple example of, a .NET project or so. you know, and there can be some, some resources here defined in the branch. So task one, internally, it will get the content out of the branch, maybe a .NET project. And then in a simple way, I will not dig into, there can be a number of things that you can define as a task. A task can be, build, get from a specific path of this branch. Every branch has some, content that can point it to where the project or solution is. And then this build machine in task one, it can build that solution and create binaries. Task two, it can be signing process. Signing of those DLLs to create either a package, or it can be, generate in a build drop. And then task three can be, create a drop. Every time a build pipeline is triggered, every build pipeline is supposed to have a unique ID. And in general, what I have seen, it's a unique number or unique an ID, which is always incrementing, and specifically a number kind of thing, which is always incrementing, so that, no two build coincide with each other. So this is the responsibility of monitoring system to make sure one check-in is taken, and it results in only one creation of a build pipeline. And build pipeline behind the scene, there are tasks along with this building task. There is also get a machine from queue. So there is a pool of machines where these builds can run.
Okay. So now, okay, complete the full flow, and then we will discuss like where what each of them does. So you are still in the build phase. So and you are yet to put the deployment part.
Yeah, correct. So what I'm saying here is, as a part of build pipeline, the first responsibility goes, a unique number or a unique build number is assigned by the machine servers, which are monitoring the branch. And this build pipeline is initiated now. And as a prereq, to run this build pipeline, it need to identify or, find a machine. There can be n number of machine pools created for this type of build pipeline or set of build pipelines. The responsibility of this one is to get machine where it can run, and it's a kind of queue behind the scene. These machine pools are nothing but they are also being monitored. Well, what is available or what is not available. As soon as a new build comes in, it try to grab a machine from a machine pool.
How do you know new build comes in? Like, is it using monitoring server? Or
no? So it is the responsibility of the build pipeline to get a machine where it can create a build. There is a separate machine pool which has an information of, or not information. Actually, machine pool is nothing but a set of machines. And a set of machine where a build can be triggered. And I believe, my understanding, it's only one build per machine. Can be, I don't know if they can be optimized, but what my understanding is, a build is running on a machine as a single instance. The build pipeline is going to get a machine where it can create its build. And then it will, once a machine is available for it to produce the build, then there will be tasks that will be performed on that machine. So like I said, task one is a .NET, build, copy the content from a branch to on that machine, which include your all the classes, or whatever is it is copied over from the master branch, the content of the repository out there, and then create, generate and run it, build it, the .NET solution or .NET project or any Java project also. I mean, like all those resources are defined there. And that's a defined way. There is a defined way to run this piece, and a fixed way. And once that build is ready in a certain folder, and then there is a signing process involved. signing process is also a separate.
Yeah, so let's take this a little bit high level. Like, don't worry about all this signing process or like the internal build tasks. You
Okay.
just take the whole thing as one build job.
Okay.
So what you get is like each commit will give you the code which you need to build. So
Yes.
you have some tasks to build, and the result of that will be kind of a binary,
Yeah.
which you are going to pick it up and propagate across to the servers across geographies, and then deploy.
Yeah.
So
So yeah, I'll cut short a bit here. From build pipeline perspective, the first objective is to get a machine where build can be generated
mhm,
from the machine pool, and it has to wait. The pipeline has to wait once the machine is available. Once a
mhm.
machine is available, it takes the machine run task 1 to 3. Task 1 and 2 are
so
creating a
so
build. Yeah.
okay, so when the machine pool is executing the build, that's what you're saying, right? Like,
Yes. Yes.
who's responsible for triggering that build here? Is it like do you have some service in your build pipeline, or like is it you have some watchers which will?
Build pipeline itself is responsible, first of all, to get a machine from a pool. There is a separate a place where as I said, machine pool. The responsibility of machine pool is also it exposes some, you can think of a machine pool is not just a set of machine and also a monitoring system on top of machine, which expose some functionality in a way that just get me a new machine from a machine pool, and it can it has a set of machine. It can give one machine to the build pipeline. So the caller here is the build pipeline itself, is to get the request from the machine pool. Once a machine is assigned, then build pipeline is the one that is step by step. When I'm saying task, those are different steps
Mhm,
as a part of build process that are running on that build machine.
mhm,
And the build machine running or creating a build out of your project. Skip the signing. So once a build or all those tasks are done on
mhm,
that machine, which
mhm,
has created the binaries that can
mhm,
be deployable, now the task comes to take that out of that machine and create a drop somewhere. This drop can be a share that is accessible to the release pipeline. It
mhm.
can be a cloud where you can put a blob.
Okay.
And then so in whatever form it is, be it an executable, be it a set of binaries, be it some JSONs, or whatever form this build is in,
Mhm,
it's a kind of one package which can be stored somewhere that the build is ready.
mhm,
And instead of going with the cloud solution here, I will, as a simple step, I will say, there is a whack, some store, some, the kind of convention builds, and then the branch name is ABC master, the ABC, and then you can say 1234.123. This everything in this folder is a build. So it's simply copying the final task here is the build pipeline is to copy the build that is generated on the machine pool and put it somewhere else. Somewhere
mhm,
else is a location where all the builds are maintained. Some are retained forever, some are deleted. That doesn't matter. Also,
mhm.
but some location. So this is the build step.
Okay. So are you using the blob store, or like are you using some shared drive here?
Yeah, I'm using a shared drive here, at least at this moment, instead
Mhm.
of trying to
Is there a reason for choosing the shared drive versus the other one?
Yeah, no, there is no specific reason. And I'm saying, when I'm saying a shared drive here, because I've been using in my team, it's a little easier for me to explain this piece. And definitely, a number of things can be, it's basically some files, some package, some zip package or non-zip package, whatever it is.
Mhm,
It's some content, it can be kept anywhere. The whole objective is to have certain path, is because this build need to be consumed by the release pipelines. And you want to make sure that, the access to the release pipeline is at certain level.
mhm. Okay. So one question here, like, so the machine pool which is running the build
Hmm.
is actually copying this to location, right?
No, the initiator of that one is a build pipeline. Build pipeline is the one that is responsible to copy the
Copy.
content from there.
Okay.
Behind the scene, it is possible, and behind the scene, when you initiate a copy job, I believe there is somebody need to monitor. So your build machine has to monitor to make sure that the copy is successful, so that it can call if it can call as if the build is done.
Okay. So what about a scenario where if your build is currently running and your machine which is running the build crashed?
If a machine that is running the build crash, the build pipeline itself is supposed to restart.
Okay.
Machine might
So
be
you
sitting
have
on.
some process in build pipeline.
Correct.
So which is actually monitoring this.
Yes. At any given point in time, the build, there are various tasks out there. It's a sequence of tasks. If something goes bad, there is also, in certain scenarios where, there is a definitely monitoring on the build pipeline as soon as, and also along with the monitoring, because these things are running behind the scene, right? When somebody check in and build is triggered automatically. So there is also a notification that goes to the subscribed people that this build has failed or something like that. There may be you might be able to create an automated solution here where you see that there is an issue in the system and you can re-trigger the build, or you could notify the you could notify whoever is listed as a subscriber to this build that build has failed, and then they can act on it to redo the task or so.
So yeah, the reason why I'm asking is because if you just list as a task, I mean, like task themselves cannot do anything like apart from doing the task, right? Like there should be a in the build pipeline, like you just listed them as tasks. Like who is executing those tasks? Like do you have some service in your build pipeline which is executing those tasks and monitoring, or?
Yeah, I totally. I think I'm getting probably where you're coming from. Well, a build pipeline is nothing but a sequence of steps defined, right?
Yes.
And build pipeline itself does not have a compute. So you need a compute where these tasks can be run and can be monitored, maybe a thread or so. Definitely, there is a set of machines. I think I missed probably. I should have stated it. There is a set of machines that are responsible to keep the state of build somewhere, and then keep monitoring that piece and keep updating somewhere that
So where do you keep the build state?
it's a separate machines.
Is it like a machine, like, or do you think you need a data store, like database?
Yeah, the state of a build pipeline has to be stored in definitely in some database or in some storage, right?
Okay.
And that storage can be manually monitored or can be monitored by the system, which is making sure the pipelines are running, and if it fails, sending a notification, or it succeeds sending notification. So there is a monitoring also on build
Can you
pipeline.
add the database component and how you monitor those? Like,
Fair enough. Let's take I'll go with the simple example, MySQL or a SQL database. A build pipeline, if I see, it's nothing but you can say it's a JSON, maybe, a JSON which has a separate
so can
component.
you tell about like what kind of data you will store for each build? So can you list some columns?
What kind of data I will store for each build? And sure. I think I will, let me make some space here. Can I get rid of this machine pool also?
Yeah, sure.
Just to make some space so that I can write.
Or if you can move down also, that will be fine.
Yeah, I think in here I can do it. Yeah, thanks. Okay. So the ask here is what all information I need to store when a build is running. So build has an instance. It's an instance of build where things are running. The build and a path to build definition. Build definition, which is nothing but defined, maybe an XML or JSON, or so that these are so many tasks, and what else it has to maintain? It has to maintain the current state. It has to maintain server or where build is running. And current state where the server is running, and I don't think of anything else.
Okay, so maybe the timestamp, or like what are the possible values of a state you define?
Yeah, when I'm saying current state, it does not mean just in progress or completed or so. It has certain more information within it. Well, definitely, it is it's in progress or completed. The timestamp of start, timestamp of completion, and what else? They can be more. Timestamp of completion, so it kicked off.
Okay, now like using this state, like how do you know like your build if some machine fails? So how do you resume from this state? Like how do you know this thing has failed? Your build crashed, and how do you resume that?
So there is a monitoring service available on top of the build pipeline. And
Okay, you are going to add another monitoring service which is going to this database.
correct, a monitoring service which is going to read the information of this build. It will poke, or it will try to get the state from the server where things are running out there. Try to get the how much it has progressed, what all it has done. In some of the tasks, instead of going in detail, you could also see the logs. It can those information can also be fetched from the server. As the logs are updating, you can see in the build pipeline also. That's one side. And the responsibility of a monitoring system on top of the build is to keep trying to get the state from the machine where the build is running, which task is complete, which task is not complete or so. And if it is not able to reach to the machine where the build is running, it could have crashed, like what you just said. In that scenario, it could have some retry.
So do you keep like along with server information, like do you also update the server heartbeat timestamp or something to monitor later?
Server heartbeat, I believe that is the responsibility in a machine pool. A machine pool is, which is taking care of all the machines that I have available in my pool where builds are running or build can be triggered. And if a machine goes out of machine pool, then it's machine pool's responsibility to take that machine out so that it does not go to any other build.
Okay, so yeah, so I think I'm fine at this point. So let's step on to the deployment piece now. Like how do you, let's say the build is complete now, and maybe you can just scroll down like without erasing, because it will be,
Sorry.
yeah.
Your point is very. Let's say, so builds.
Builds are done now. Like how do you pick that binary that you have completed from the location where you stored those binary and deploy to different application servers across the geographies? So how does it work?
So the start here is this is the build path where a build is ready for deploy. Build path. The build is ready here to be deployed on production. Now I can definitely relate it to with one of our release process, as where things are running. I'm going to take a simple path where I'm deploying a data factory or something is to cloud. And this release is a manual process. this release is, because
No,
things are.
I mean, like, yeah, now I'm expecting it as an automated. I mean, like, that's why I said, like, you have to pick this and automatically, I mean, like, this deployment step or process that you're going to design, it's
Mhm.
going to take those binary output that build has generated.
Mhm.
And probably, I mean, like, since if you have servers in India, you have servers in US, you have in Europe, Australia, like different regions, like all these application servers can be anywhere in this world. And you have to take this binary and copy those across to all the servers and deploy. And yeah.
Fair enough. I think if you want to integrate, if you would like me to integrate this release process itself along with the build, I think I erased something here. So my bad. I would have gone back to the same. Um, in this build path, if once this has to be monitored by somebody, like the Git check-in or the branch check-in that was done for
Mhm,
the build, which was triggering the build definition to generate a build. The similar
mhm,
to that thing, it has also need to be done for release. So that has to be done once a build is ready. You could, I can say it like a policy itself, where in the branch it was defined that once the check-in has been done to the master branch, and it can trigger the build. The next step, let's say this information is already defined in the policies of the branch itself. Once the build is ready, just take it to deployment.
so how do you copy your build to all the regions? Like, what is your strategy?
How do I copy the build to? So when the release is started,
Mm-hmm,
the main thing for a release is the artifacts that it is trying to deploy,
mm-hmm, yes.
right? So the very first thing, this artifact is going to point to this one,
Mm-hmm, yes.
right? Now every release definition, this is the release, and there is a release definition. A release definition is nothing but all the metadata or the information that what need to be done with respect to this release. Um,
Mm-hmm,
so this release definition is some information or along with some steps defined that that you need to do this, you need to do that, a step-by-step information of how things are supposed to be deployed. Now since you are saying this release is going to get automatically deployed to servers across the globe or so. So it removes that information at all that somebody need to approve this piece, or those informations are fully gone from here. And because if in automated system, I believe approvals and all that, there's nothing there at this moment. So I'm not gonna go to that particular piece of release where people approve different kind of approvals. Now in this release, the release is already defined for a given branch. The content of these builds are supposed to be taken to so and so servers across the globe. Once a release is initiated.
I mean, like, so do you mean like you initiate release from across the servers by pointing the, I mean, like by taking the binary from the same location? You don't do any replication or like copy this file across?
uh, it's a pretty fair point that you just brought. Now,
Mhm,
well, this artifact or the build path, we do not need to do as a prereq for the release, right? Because a trigger point for the release, it is not necessarily needed be across a, you know, uh, uh, it need not be a prereq here to the build. And
mhm,
I think I'm getting your point. Probably you are saying is like, this build could be significantly large,
mhm.
and if the release
Yeah,
itself is.
it can be in gigabytes or yeah, I mean like, yeah, I mean like gigabytes, not terabytes, definitely. So yeah.
So what I'm thinking of this piece is, when generating these builds, and if these kind of requirements are there where build can be significantly large and needed across the globe, um, it might make sense to have this thing done as a part of build step itself, that when build is copied over, like I was describing earlier, when build was taken from the build machine, there are two things that can be done here. What I see is like either, we can define the steps here that to make this build available in so and so regions, right? As a part of build step itself. Now, second thing that can be done here is wherever we are putting this build, like I said, vac builds and all that. Now this path can be replicated behind the scene as soon as a new folder or as a new something that comes in to this path. There can be a separate process where this build can be replicated into multiple regions.
So can you explain that process?
Yeah. I will go with the replication here actually.
So what kind of replication do you use?
It could be a blob-based Azure replication. It could be, your the replication
Do
of
you
your.
mean like synchronous or like asynchronous? Like how do you replicate?
It will be async. Putting a sync actually, it could create some trouble. I would go with the async replication. Like in a distributed system, like you make changes on your box, your drive is synced in an async way to some other servers, across different region or so, right? So what I'm thinking of this path, the builds path, which is when I'm trying to access here in US, it will point to some location in the US. When this path itself is being accessed in India or Europe or so, this can be translated to when I'm saying vac, it could be something else as a prefix here, right? So what I'm saying is this path itself can resolve it to a region specific path if available. What I will go with, and definitely async replication here instead of going with a sync replication. That itself has a some troubles. If I go with async, and what we intend here as a part of this process is to release immediately as the build is ready, right? And if I define this build path in an async way, it is possible the release has gone to that region, but the build has not been copied yet. So that's a caveat here. And now we might.
What do you mean by release has gone but not the build?
Okay.
So how do you trigger the release? Is it like
there is a primary location that I'm stating here when the build is running. Let's say in the primary location is US, where a build has been copied over as a first copy that came out of a build machine and it was placed somewhere. Now this could be, the region here is US, right? And then now this copy is, this is a primary source of the data, which is getting replicated in an async way in different regions across the globe.
okay.
Right, in an async way. And another requirement that you have put here is, as the build is ready, the release should also be started in an automated way. Now, the build itself is getting in an async way to take an example in Europe, right? This was a 100 GB build. Now it is taking time due to some network issues or something, it is taking time to replicate into Europe region, but my release has started already for Europe.
So yeah, so that's my, sorry, my thought. So how do you start the build without like the build file is being copied? I mean, like, sorry, a release.
Okay.
How do you start the deployment without your binary being copied?
Yeah, I'm keeping that path, the regional path, out of scope of this build or release here, right? What I'm defining here is this information that the build is in US or so, this information or this path to be resolved automatically depending on where the release is running. So when I'm running a path here in US, it can resolve to a nearby path within where to get these binaries from. It can resolve it nearby location, but when it is in Europe, the nearby location could be a file server in the Europe region itself, right? And then this will be resolved there itself. Does that make sense?
Okay.
Yeah. What I'm saying is the path resolution to the build, depending on the region, is to be auto-resolved instead of a specific path.
So how, I mean, like I'm confused about that auto resolve. So behind the scenes, like you are doing like the async replication and that will be same, or
Well,
is
again,
it like a drive, like a share,
yeah, like a shared
like a
drive.
Google Drive or something?
Uh, Possibly like a Google Drive. What I'm saying here is there is a, this is a fixed path, right? Which
Mm-hmm.
comes with the artifact. Now, this path, which is a prefix to where the location is actually the
Mm-hmm.
parent folder or so, I'm saying this piece to be auto resolved in
Okay.
where you are running, in which region you are running,
Okay. Okay. Got it. Got it. Mm-hmm.
right? So
Mm-hmm.
the replication or the copy of a primary path. So what I'm saying here is my build servers are only in US. So I'm not putting it, at least this can be changed also later on. But what I'm saying, at least at this moment, is my build servers are in US, machine pool is in US. The copy from those machines are going to a close by location in the US only, probably in the same data center or so. Now this 100 GB worth of data is getting async replicated into various regions. Like you have put a requirement where, right, the data is significantly large, which could create trouble when we are releasing it across the globe or so. So instead of copying that data as a part of release itself, you're saying like, that data, if that is available directly in that region, this will expedite the release process.
I mean, like, could you draw this like the process that you're talking about, like step by step flow, like?
Sure.
Mhm.
So there is a and what I'm saying here is I'll take an example of cloud here in Azure. Sorry, right? So there is a concept of geo-redundant storage,
Mhm.
right? Geo-redundant. So what I'm saying is this path is available to me in Azure, where I'm dropping from a build machines the path of a build, right? And behind the scene, I am replicating this path to different countries or different places where I need to deploy my release to data centers across different
Mhm.
part of the globe. Now this part, when I'm saying the build or drop, this information is a prefix. Now this prefix, I can say this is let's say it's a build location, right? When I'm going to deploy in US, it knows what is this. You can simply think of one in a simple way. Maybe it's an environment variable also as a build location, where this is defined that this is a build US drop ABC. Now in geo redundant storage, when this drop folder is getting replicated, this will get replicated into a build Europe, and then drop, and then the kind of postfix here, right? So this variable, when the release will run in Europe, this variable is known to the Europe, and they will look for this particular build to be available in that region.
Okay. So how do you know like this was successfully copied or not? Like that was my question. I mean,
Okay.
like if it was in the process of copying or replicating.
Yeah. So the reason why I'm putting it in an async way is, and this release itself, since it is an async way, so it is expected that, while a release is triggered in Europe region, that build is yet to be copied completely, right? So there is a, when this build is getting, when this package is fully available. Okay, so your question, okay, I think your point is fully valid. I did not think about this piece earlier. Is what if only a partial copy is done and not a full copy?
Mm-hmm.
So what I'll say, I think it's a pretty valid point what you have. I think I need to think of a solution here. And if it is a full, if it is a one file or a one zip package, let's say,
Mm-hmm.
the geo-redundant itself is supposed to, not make it available unless it is fully copied over. A partial something is not available. This is a feature that is already there, at least in uh, uh, in Azure here. When you're copying the content from location A to B, if it's a one package, then that package is not available unless it is fully copied over.
Mm-hmm.
right?
How do you verify that integrity? I mean, like this. I mean, like the file is fully copied or not? Like.
Okay. So I am not, at least at this moment, I am not building a geo-redundant solution. So I will rely on if something is copied over from a location A to B, it is intact.
I mean, like, how do you verify? I mean, like, that was my question, right? Like,
Okay. And availability of file is an indicative of that it has been copied over.
okay, so you will make sure that this
Build.zip.
okay, you will rely on some system which will only make it available.
Yeah, I'm relying on the geo-redundant replication of, let's say, I'll specifically name Azure here, geo-redundant solution where, when a file is copied over behind the scene to a folder, even if it is, getting copied over step by step, but it's a partial copy, but a partial copy is not available. For release to, if it is not available, it means it's either not there or it is in the process of getting copied.
Okay.
Right.
So got it. So what are the steps like after this? Like now you have got file, and now your deployment process triggered, and do you have any system?
Yeah, I mean, so like I said, it's a async copy, async replication.
No, that's fine. I mean, like, can you just briefly summarize the steps after that? And then, like, I think we are already at 1 hour, so we can quickly wrap up after that.
So the build is getting copied over separately, but when the release will go to Europe, this release is going to, look for the build is there or not, or there is some time defined here in the release is to keep trying to wait for that build to be available. And when that build is available, it will trigger itself. And there will be certain timeout defined here in the release, in the European release. If the build is not available, then it will fail and it will notify, or there's a monitoring on every release or build, then it will notify that this release has failed in a given region and some action need to be taken out there by on call or so. Right. And in the release, like I think we discussed already in the build. So release definition itself is nothing but a JSON or a steps of which is defined in a certain format in a file. Let's go with the JSON. JSON has a steps that are defined in the release. A step, a deployment step is to be use this particular build. I will use, first of all, it also has to get a compute source. Release itself cannot do things on its own. It has to get some information. Sorry, I think a release also has to run on a machine pool. Machine pool where it will pick machine and then this release is going to run. One thing that we discussed earlier on with the build, similar thing here also, to keep a state of a release in what all steps it has run. Similar information started, ended or so, which we discussed earlier. So this database will keep the current state, and there is a monitoring also involved here, some monitoring service on this release. If something goes bad or succeed or a failure or so, to notify to the subscriber of this release. Now, the task in this particular, the prime task involved here is to, once a machine is assigned, is to use the build to deploy to application servers. Right now, since we are talking about this release, and this release, can have what all data centers it is going to deploy to. Let's assume that every data center that it is going to deploy to is a separate, it's a separate machine itself. So in that scenario, either I have two options here. Either I, create a separate release for a separate data center, or in one release, I take it as a steps to all the data centers across the globe. And I think I will choose as a release, a separate release for a separate region as such. So that, and we know that at least the way, the reason why I'm choosing this, because there could be a different artifacts or the different variables that are needed for a given release. As an example, I'll say it's possible in Europe, all the deployments are same, all the machines are same, maybe content is same, and in US or in India, or they are different variables. So I will choose my release pipeline in such a way. So here in this example, when the build is completed, it will trigger multiple releases across the globe. I'm keeping it as a reference to release Europe. In release Europe, also, when a task is created, get this build will be taken from Geo-Redundant Storage of Europe, and then deploy to data center 1. There will be a separate step for every data center, deploy DC 2. And all these steps that are defined, deploy to data center 1, deploy to data center 2, those are being done on separate machines from the machine pool. Now, when this thing is done, when you deploy, you also want to make sure your services are not down. So to make it highly available, there's a concept of scale unit, and we can keep n number of scale units in the data center. Let's say for a process, what we are deploying is a process that has 4 machines.
One question here. So where does this machine pools which run the release exist?
Every release,
and do you need a machine pool to deploy, or like can you directly run this deploys on application servers? And another thing is, how do you verify that this build is deployed across all the regions?
Fair enough. So the first step here is what I said is like, I will have a separate releases, different releases for a different regions or so. And in this example, I'm taking, so when a build is ready, multiple releases will be created. And every release is going to have, people who are subscriber or developer or on-call engineering team or so, as a subscriber to that release. If anything happened with that release, they will get a notified, be it a creation of an incident, be it by a phone call or so, they will be notified if something goes bad, right? Some kind of monitoring mechanism that makes sure that, any failure or so, it reaches to the directly responds to DRI for that group or the team at that time when this thing happened, so that they can take action, right? This is for monitoring. And I'm sorry, I forgot. What was the other question?
So how do you verify this? I mean, like this is deployed across all the regions which you intended for.
Yeah. So if the responsibility or if the monitoring is on the for across the region is only on one side, then every release will have a, so since it is an automated system, if something fails behind the scene, that failure has to be automatically engage an on-call individual. The automated engagement is by a monitoring system that is looking at all the releases that are there in progress, or the things that have failed behind the scene. Is to we use ICM here in Microsoft, at least in my team. So those ICMs, in such a case when your pipeline is failing, severity of a high severity ICM is generated, which involves a call to a DRI, right? He will get a phone call, he has to acknowledge and then come on the bridge and then look at the issues and then try to fix it or take action accordingly. Now, if it's a fully automated system where everything is running fine, things are completed, only a kind of notification in form of email or so, it is supposed to come that everything is running fine, there is no issue. Otherwise, if there is an issue, it is supposed to raise an alarm.
Okay, so I think we are almost done. So can you wrap up and just say like what is your system drawbacks?
Sure.
And yeah, and what?
At least this thing I didn't think of earlier. I think I should have thought about this earlier. Where which you asked me. Having a location build. I could do a better job there probably. Do it in a right way. But And as far as drawbacks
Any
are
other trade-offs? I mean, like what you think is good, like where?
see, as long as one thing I, at least that my understanding or my experience is like, as long as you have a system that can, correctly engage the right individual in case of a failure or so, you can take action and then fix it. So monitoring is the key here. When a system is automated fully, like what you just described here, you check in, it goes to build, it goes to deploy, and it's a fully automated system. It is highly desired, or it's kind of must have that a good monitoring must be in place where an individual can be engaged in case of such failures. Right now, and the example I gave, I believe these are, in terms of build or deploy, these are in use already in my team. And as far as I have not worked on this, where, you need to, it's a complex design where you need to think of, multiple releases across the globe. And in at least, there are a lot of components involved, which in today's our day-to-day life, which we assume that those are not assume, I mean, which are already there, in the build system to help us, which maybe I also don't have too much of understanding how they work behind the scene also. But these kind of capabilities are all out there.
Okay. Okay, I think we are done. Like, I think we are already over 10 minutes or so. So let's conclude it here and ask for feedback from the audience, and then I'll give my feedback later.
Okay.
Thank you very much for participating in this mock interview, Hitesh. Appreciate your effort. And yeah.
Thank you, Naga. It was a pretty good question, I must say. And I had to scratch my head for this problem. And even if there are things that I'm already doing in my team also, similar, not to that big extent or so, but it's a pretty good problem to solve. Pretty big.
Okay. Yeah, let's ask the audience for feedback, and then I'll give mine little later. Let me write down what I think. Yeah, just take the feedback as constructive, nothing to offend, because it's all like we are all learning. So yeah, audience, like when you're giving feedback, you can give it to Hitesh or me. So whatever you think we could have done better. Okay. Anyone? The forum is open now.
I have some points to share. So I noticed in the beginning, I think around 20 minutes was spent on requirements analysis. And then suddenly there was a realization that a long time has passed. So let's focus on the design instead, rather than focusing more on the requirements. So I see some scope of improvement there, like because the requirements that we wanted, I think the interview, the candidate wanted to see, like he wasn't comfortable like that he has all the requirements, but then still, just to save time, I think decided to proceed. Then one thing I wanted to see in the build component was the build service. Like there needs to be a REST service that takes the call to say that, hey, this is my input branch, this is my hash commit, I take these as input, and then I create a build task, a pipeline task that is gonna process like the template for that branch and then run it using the appropriate machine. So that service, I didn't see it anywhere in the system design.
Yeah, good point. Like, yeah, I also agree with that. And even your first point, like, is there any other feedback?
Yeah, so I see there was a lot of discussion about what all tasks the pipeline would be doing. I'm not sure that was necessary because the interviewer wasn't much interested in those aspects. rather, I think a way to actually shorten that time is to just say, hey, there's going to be a build template with all the steps. The build service is going to take that template and just trigger the execution. Another thing to keep in mind was like there has to be some build queue, right? There's going to be a lot of builds. So the build service is also managing input from these queue. It's basically taking inputs from this queue and scheduling them. So that build queue, I don't think we talked about that in the design. And then for the machine pool, so there has to be another service, right, for machine selection.
Good morning.
Sorry?
I think it was some disturbance, like you can proceed. Yeah.
Okay. Is it better now?
Yeah.
Yeah.
So there has to be some service that basically manages all the machines, and then you pass in that, hey, this is the SKU of the machine, or this is the type of machine I want based on the, like my code changes. If it's, let's say, Java repository, I'll have, I want a machine which has the Java SDK installed, all the stuff needed to build that stuff, sign that stuff, all the things. So I want to say, hey, this is the kind of machine I want. So I pass in the type of the machine, and then the machine, the service that manages the machine pools is going to take that as input. It's going to check its own queue. It's going to have its own queue of the VMs it has of each type. And then there's going to be a process that you could introduce a messaging queue which takes care of like, hey, these are the available machines. These are the requests that I have. I don't have available machines, so some requests might have to wait. So I didn't see that come up in the discussion. So that's another service that was missing. So in terms of system design, I see it as the major thing is you have to design the high-level components. Like you have to define the services. Each service should have clear input and output criteria. What is the exact data that is being transferred across services? Am I passing the build ID? Am I passing the type of the machine SKU I want? Like, so we need to be clear, like what is the input and output for each of the services? How are we getting that input and output? And like it's throughout the process, not just for build, it's for the release and the deployment process as well. And I know there was some discussion about like, hey, we'll copy the build to a file share. And when asked for the reason, like why file share, there was no specific reason. So in general, one part of a system design interview is evaluating why a candidate chooses a specific technology, why a candidate prefers one technology over the other. So it's important to justify the choices. In this case, I think like if I was there, I'd probably choose a blob storage, but let's say if we choose a file share. So let's say in this case, it was Azure Files. We want to justify why are we choosing the SMB protocol to connect? Is it making copying of files easier? Like how is it helping? So we can pick any technology, doesn't really matter, but we have to have justifications for why we are going for that. So that was another aspect I felt like there was not clear signal as to like why a candidate would choose one technology over the other. I mean, that's an important thing I'm evaluating, like how is the trade-off done among different technologies. Then there was some discussion about the build monitoring service. So there's going to be a service that monitors the build, but it wasn't clear how it's going to operate. So some things to add on to that could be, hey, this service, let's say, is going to operate on a polling mechanism. It's going to poll every few seconds, and it's going to request the logs for that duration from the machine. I mean, you need to see the updated continuous logs, right? So it's going to poll the machine. It's going to poll the agent running on the machine. So there's going to be an agent running on the machine that's going to transfer that logs and expose it through a REST service. So that build monitoring service is going to poll the machine, the agent on that machine, and that agent is going to return the logs since the last time it was queried. And like, how do we know? So there was a question that, what if the server crashes? How are you going to handle that? So if the server crashes, I mean, the one way to detect is like, so this is my build monitoring service polling constantly. And if it doesn't return any meaningful results for like 10 minutes, I time out automatically and I mark the build as failed. irrespective of how the task has been proceeding on that machine, because the timeout that I had configured has passed and I don't have enough heartbeat signals or like the result signals from the server. So there are ways to handle it. So the interviewer wants to talk about these kind of things, like how do you handle these kind of scenarios? It there's not much focus on like what are the features. I mean, I'm sure like everybody has worked on build and release systems, and like they all know the features. Like, but the focus is on this, like how are the things working behind the scenes? What services are running? How are they communicating with each other? So that's one part. And then yeah, there was one question about like copying the builds asynchronously. I know it's a debatable topic, but what I'm looking for is like I want the design to be simple. It just because asynchronous transfer could be better in certain situations doesn't mean it's better in this one. So in this case, I would copy builds synchronously. So this makes sure that if, let's say, a machine has all the logs, the build has succeeded. Now I want to copy the builds to, let's say, another location. Until I've copied all those bits, if the machine goes down, in the meantime, I've lost the build. So I indicated that the build has succeeded, but it hasn't actually succeeded. So there's no way to recover from that if I lose that machine forever. So I only want to mark the build as succeeded when I have all the bits copied to the desired location. Until that is done, so that's the synchronous step. It cannot be asynchronous. So I copy it synchronously at least one place. Now from this one place, if I want to copy it elsewhere, that transfer could be asynchronous. So that's fine. But yeah, in general, the design should be as simple as possible, like no unnecessary steps, no complexity. And so there was another question about, hey, how are we gonna know like the build has been copied completely, or is it just partially copied? So a common technique that is used is, hey, I have all the bits that I need. I'm just going to compress it to a zip file. And this is the zip file. I know the hash for that zip file. I'm going to copy the zip file to the location. And once I'm able to validate that the hash for the destination file is same as the hash for the source file that I was trying to copy, I know the copy is complete. That is the time I mark the build as successful. Now, any release can pick this build up and run it. And so the release decides which regions the build is going to be deployed. So if I have 20 regions, the release is going to know which 20 regions it's going to be deployed. So before the release is triggered, I don't know which regions I need to copy it to. So I'm not going to copy the build anywhere unless I know which regions it needs to be copied to. And again, like if the build is small, 2 MB, 5 MB, 10 MB, there's not going to be issue like transferring it over like the subcontinents. So it's fine. It could be done as a part of release process. But in case the build is huge, like several GBs, then yes, we may need asynchronous transfer, but that needs to be predefined in the template. And that will be a part of the build process. So in between build and release, the only thing is build is generated its artifacts, it is done. Now the release is going to pick up from there. So in this way, there's not going to be any issue of like partial copies or anything like that. And then somewhere down the line, there was some implicit assumption about the system being a continuous integration and a continuous deployment system. I would prefer to call it out in the interview. Like if you're making any assumptions like this, which influence the design, it's better to just call them out. So interviewer knows, hey, you're not just making them up because it's simpler for you. You actually know you're making these conscious choices. Not every system is like that. The system that the interviewer wanted you to design could have been different. So, and then there was one question about like, how do you know whether the deployment is complete? And the response to this, I mean, it wasn't really clear. I did hear about the alerting system, like there's an ICM component which is going to raise alerts. I didn't see much details about how is it going to raise alerts. So how is it going to detect that some like the deployment is complete or there's something wrong? So one technique that many teams use, actually most teams use, I'm pretty sure your team uses as well, is so once the deployment is complete, there has to be some check, a health check. And it's part of the release process. You don't know release has succeeded or not until that health check succeeds. So if it's a service, let's say if it's a service you're deploying, you check, you make requests to the service, you ensure that appropriate response is coming from the service. And that's how you know that the service deployment is complete. How do you know? How do you raise an alarm if something goes wrong? I mean, there are going to be logs generated. So the ICM component is going to have an agent running there on the machine, which is actually on the main production machines, which is going to send logs. And these are the logs the monitor is going to check. As soon as it detects logs, which is unexpected, it's going to raise an alert. So again, I didn't see the connecting layer between these two. Like there has to be logs, or there has to be service requests to determine the health of the system. That's how we know the deployment is complete. And so it's a very interesting problem, like build, deployment, like build, release, and deployment. And I think deployment stage is the place where there's a lot of scope to demonstrate your system design skills. I'm sure you've practiced a lot. You know a lot of the different skills, but unless you have enough time spared for the deployment stage, it's hard to demonstrate all those skills. So the goal of the interview is utilize the time wisely, so you're able to demonstrate all the skills that you know. I mean, you have to inject all those skills, even though the interviewer is not specifically asking for it. So yeah, these are just my high-level thoughts. I'm open to questions or any follow-ups.
Yeah, I really appreciate your feedback, Bilash. I mean, it was excellent feedback, and I have some, I can add on my own at the end. So yeah,
one thing, Naga, before you add your feedback. So Abhilash, it was a very great summary, and I think you have summarized things very well. I would be interested if you would have some time, you could take a session, because I see that you have a very good knowledge about this topic, if you can. Yeah.
Sure, yeah, I'd be happy to work with it and set up something.
Thank you. I think it was a pretty great feedback that you provided, and I think though I have one question, Vilash, as a part of deployment, and which I have not seen myself actually, doing this piece, in my teams or so, the health check that you talked about as a part of the deployment itself. What I have seen is a deployment could succeed, but the service might not even light up at all. And instead of making that as a part of the deployment itself, it's a health monitoring on your service itself. The separate monitoring on your environment or application servers, which is the one that is supposed to create an alert instead of putting it in a release field. Isn't that is supposed to go to your service monitoring model? And I believe the deployment is more or less responsible to, you deploy the stuff on the application servers and then just try to light up.
I meant what I think Abhilash was talking about is the true deployment is just a deployment, but your release process will generally involve, right after the deployment, there should be another thing which you trigger, which is your health services for your system, to verify that your deployment succeeded correctly.
So my question
it's kind of
is health services are always up and running instead of irrespective of the deployment when it's happening or not, but health checks are stuff should already be up and running all the time, and trying to communicate and make sure that other services are up.
Yeah, I can elaborate on that. So you'll see a lot of production systems where they just deploy the bits and then the release is done. Release has succeeded.
Yep.
But that's not the ideal thing. I mean, if I join a team like that, one change I would make to the release process is to introduce service monitoring as a part of the release process. So once the bits are deployed, that doesn't really mean that you succeeded, your release succeeded. Your release is considered successful only if the bits you deployed are healthy. In case those are not healthy, the release should take care of the rollback of that bit. So part of the way I see a release is the release process happens, the bits are deployed. We monitor the state of the service. It's not just a health check that the machines are running. It's also that the bits are deployed are healthy. So I need to define a specific criteria saying that, hey, if I make this basic call, this fundamental call to the service, which is, let's say, my BVT, and if it returns a success code, then I consider that my service is running successfully. There are no crash issues or no issues like getting the service started. Maybe I have to wait 1 minute, 2 minutes for the service to completely load and get initialized or warmed up. But once I know that the service is returning a successful response, I know that the bits I have deployed are healthy. In case they are not for a certain period of time, as a part of the release process, I roll back that build and then I switch to the old bits. And there are various techniques to switch as well. So interviewers can even go into detail on that as long as you have time available. But it's a very interesting problem. Not all teams do it like the right way. I would say very few teams do it the right way, but you see the designs for the teams that can trust their continuous employment, continuous deployment systems. Those are the teams that have systems like these built as part of their release. And then there's a separate service monitoring, which ensures that, okay, once you've deployed healthy bits, over time, if there is any degradation in the service, or if there are any anomalies or like weird behaviors or like any errors being observed in the system, those are being caught by the service monitoring that is being done. But if those errors happen at the time of deployment, ideally, I would expect the release to handle it. But then again, it's not like you won't find perfect systems in many of the companies, in many of the teams, but the goal is always to strive for moving to that stage.
Sounds good. Thanks.
Hey, Naga.
Hey, Bhavesh, you have some feedback or?
Yeah, but you can go ahead and then I can go.
Yeah, you can go ahead.
Okay, yeah, so it was a really great discussion. I think, yeah, all the feedbacks are great. I just have a couple of thoughts to add. I think initially, when you put this question, I was also start thinking, how we can, achieve this. And then I think Abhishek came back with, some requirement that is really great to start, and then he gets started, right? I think, I'm not sure what you were trying to do, but I think you were trying to, push towards there should be some queue mechanism, when a lot of things are happening. And there's no discussion of queue came into the picture. And second thing is that what I was thinking is that, see, whether we have automated deployment or not, we have a system that builds, right? And we have a system that deploy, right? And when we say that I'm going to do automated build, basically I'm building a process that basically kind of orchestrates this piece together, or release management, right? So without this process also, you can basically build, you can deploy. That should be basic building blocks available to it. And this system just utilize and connect those blocks. Basically it automatically figure out, oh, there's a check-in happen, I need to make a build. I make a build and I deploy using the existing system and basically do reporting and failure reporting and success reporting, whatever I need to do. And the second thing is that queuing need to be discussed in this case, because there are a lot of things can happen. You also want to basically control how many builds are generated by branch and other things basically. So queuing need to be part of this discussion that I thought that was missing.
Okay, thank you, Bhavesh. Any feedback for me or like?
So no, I think so whatever you were trying to give a lot of hints and a lot of let's see if you were trying to basically control the discussion. That was I think it's a good feedback.
Okay. Any others to give feedback, or like can I do mine?
So I have one point to share. So in the beginning, as I already mentioned, like I think for 20-25 minutes, most of the discussion was about requirements clarification, and the output wasn't as concrete. Like it wasn't actually, it didn't actually list down all requirements. So in this case, like so if there's a lot of time which has already passed, like if I'm interviewing someone, I'd actually give them more hints as to, hey, this is exactly, these are the things I'm looking for. Like, how would you build system operate? Like, what are all the services you're going to have? How are they going to interact? I would point them in the right direction. Like, because I see that, okay, they're nervous. They're a bit nervous. You can feel that. And you don't want them to waste too much time. Your goal is to actually get the best out of them. They know a lot of things. You want to make sure that they're able to demonstrate these things in the interview. So how am I going to do that? I can do that by pointing them in the right direction, exactly telling them, hey, these are the exact things I'm looking for. Don't focus on these details. I know at some places you did mention, hey, don't go too much into the build task and all. Like, so those were all good. I know you were asking good questions throughout. Like you were asking, hey, how would you were asking the things that you actually care about. So that was great throughout the interview. But in the beginning, if you already see a candidate is getting nervous and they're already like, they know that they might be running out of time because they've spent 15 minutes and they don't have much results. So in that case, it's always good to actually point them directly, hey, these are the things I'm looking for. Just focus on these, forget about the others, and make them calm down. Like, it's okay. It's okay if they miss certain aspects. They don't need to come up with a perfect design, cover all the components. They just need to demonstrate the skills of one or two specific components that you care about.
Okay.
So that's going to be my suggestion.
Yeah. Thank you. I think that was good feedback for me also. And so, and with regards to requirements, I agree that we spent a little more time there, and partly I was confused there because I thought like maybe he's laying out some steps for high level design, and then and then I thought like maybe he's just discussing of his own experience and probably making assumptions and trying to align on the scope. So one thing which I still see, Hitesh, you missed is like the non-functional requirements. Like you didn't ask whether how much of availability I'm expecting for the system. I mean, like I think there are two ways we can do this. Like sometimes like the interviewer gives all of that requirements, but like if not, like I expect like the interviewee to ask questions about like what non-functional requirements I care about. So in this case, like I mean, like with respect to the availability and stuff. And that is one feedback. And on like when you're talking about high level design, I agree with Abhilash and Bhavesh that like I was pushing towards like a queue kind of a mechanism, and also I was expecting some service components. I know you're trying to mention all the systems, machine tools, and data. I mean, like the build task and the monitoring server and all. But when you talk about all this, like you also need to talk about what services you're going to build along the way, which trigger, which act as a input or output mechanism. And one thing, on the file share, like I know you mentioned initially about like the cloud blob storage. So, and then like you immediately switch to file share. So there, like, I also echo the Abhi's feedback, like why are you making the switch? Like I thought, like even I was thinking that like you will switch back to blob, but like you were there in the file kind of storage, but that's okay. Like if you would have given me the reason, a good reason, that would have been fine. And the sync versus async, I think one key feedback there is like I'm okay with async, but like the main issue there is you have to find out like how you are going to make this. So using async will actually make you add design or like some verify mechanism to make sure that your file copy was successful and you verifying the hash like is one mechanism like we mentioned. And so ensure you don't lose builds. Yeah, that is one key step that like you at least need to replicate the build binary to one or two more environments. So otherwise it will become single point of failure. So that is one thing you need to just keep in mind whenever you're designing. Always think about, can this be a single point of failure? Uh, so like think about like how you avoid that. And and one thing which I generally noticed is like I think it based on your experience, you're trying to bring some terms or like some systems which you have been using, and implicitly you're talking about them along with this design. So sometimes I'm getting confused, like whether you want to use them here or like you are just trying to convey that like you have used these systems um, in your project. And yeah, I think rest of the feedback is I think other people already covered. So yeah, that's all.
Thank you, Naga. It was amazing review. It's been a while I gave these interviews. I do take.
Yeah, so it's yeah. Main thing is like just learn from the I mean like feedback, and next time we need to go stronger and do better.
Yeah, I mean, I totally get. I believe, the two system itself. I believe the build, and then I also got confused initially because the build itself is a big component. Release itself is a big component.
Yes,
when
yes.
when you asked initially to build both of them, so I just wanted to be sure of like, is this, will I be able to cover up, and I spent a lot of time in asking the requirement around what build and what release, and all, instead of drawing the right blocks and all that. And you are very much right. I got confused in between, should I put, because these things are everywhere used. Actually, we are also using it, right, across companies or across teams. So, and definitely, I started with Azure Blob as a storage because that's probably the better one, which you provide resiliency behind the scene of a single point of failure or so. But then, due to the time constraint, spending so much time on the build, that confused me, and I was trying to, say some component. I believe people shared the feedback here in terms of queues and all that, right? And so I should have actually, created good blocks on those instead of writing this passive. I think it's a learning. Instead of putting the task 1, 2, 3, 4 and all that, and then somebody gave a pretty good feedback. Just say it's a build template. Right? And so if I would have put, definitely the right blocks out there, which the responsibility, just giving it instead of going into the details and all. And I think all this started off with the time, which led me, try to, move fast because I wanted to, go to the release component as well. So, given the time constraint also, because, you raise both the requirements of build and so in that hurry of, taking significant time initially in the requirement gathering, and definitely I wanted to get non-functional, but, due to time constraint, and I jumped so fast on things, and creating some confusion between you and me. And that I love that Bhavesh feedback, that at the end of the release, and that auto rollback, I would definitely, try to see if I can do in my team also that kind of, build this thing. This is pretty nice. And I think that point that you guys shared that, since we know that the release is going to be deployed to other region, why do I make it asynchronous? I should not make it asynchronous. Now, the second point comes like, should I make it sync in the build itself? If build does not know where it's going to get replicated or where it's going to go to release, maybe a release is the path which can take as a first step to copy things and then start the deployment. I think there is a good improvement. and that I need to do on my, presenting my skills in a right way. And I think that the time constraint messed it a little bit.
Thank you. So let's see, like, if finally, like, last call for any other feedback, and then maybe we can talk about the next session. Okay, then I'll stop recording, and then Abhilash, like, please stay online, and everyone stay online. We'll talk about next session.